We are covering the block counting subtest of the AFOQT with a specific focus on a concept that trips up many candidates: hidden block inference. On this test, you'll see a three-dimensional pile of blocks and be asked how many other blocks a specific numbered block is touching. The critical rule to remember is that blocks are only considered touching if their faces are in contact, not just their corners or edges. The test makers will deliberately design these piles to test your spatial reasoning, and a key part of that is forcing you to account for blocks you cannot see. A common exam trap is presenting a block that appears to be floating in mid-air. For example, imagine a column of 3 blocks stacked vertically. Next to it, there is a single block on the ground. Now, picture the target block positioned directly on top of that single block, but also horizontally adjacent to the middle block of the 3-block column. When asked how many blocks the target block is touching, you can see it touches the block below it and the block to its side. However, if there's another block stacked on top of the target block, it might look like it's floating. Physics dictates that this is impossible. There must be a block underneath it for support. That supporting block is the target block. The real trick comes when a block in a higher layer is offset. Imagine a block on the 3rd level of a pile that is visibly supported by a block on the 2nd level. But if that 3rd level block extends backward out of your line of sight, you must infer that there is another hidden block on the 2nd level supporting its back half. The AFOQT loves to create these scenarios where you must build a complete mental model of the structure, including its hidden supports. You must systematically check all 6 faces of the target block: top, bottom, front, back, left, and right. A common mistake is only counting the visible connections and forgetting to check for unseen blocks, especially the one directly underneath. To master this, adopt the mental shortcut: if it's in the air, a block must be there. This phrase serves as a constant reminder that every block above the ground floor must be fully supported. If you see a block that seems to defy gravity, your first action should be to mentally insert its hidden support block and include that in your count. This isn't just about counting, it's about structural logic. The block counting section is fast, giving you only about 9 seconds per question. Therefore, you cannot afford to second-guess your inferences. Practice is key to developing the intuition needed to quickly and accurately visualize the hidden geometry of the block piles. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.